technique in which a linear function is maximized or minimized when subjected to various constraints. So others, they normally say this linear programming technique, it's normally used to allocate resources, the scarce resources, using different methods. Under linear programming, we have method like your graphical method. We are talking about the LP. They call it LP. So LP, it means linear programming. And I'm saying others, they define or they refer it as a mathematical technique. They say the mathematical technique in which a linear function is max, which stands for maximum, or maximize.
Sorry,
Apologies,
sorry,
doctor. We can't see your screen.
Yeah.
Can see my screen?
Yes.
Okay, I'm sorry about it. Let me try to share it, you guys. Okay, are you able to see now?
Yes, thank you.
Okay, I was explaining that this LP, which is linear programming, the abbreviation is LP, stands for linear programming. And I was saying other authors, they refer it as a mathematical modeling in which a linear function is maximized or minimized when subjected to various constraints. So this is the definition. But in a nutshell, I would say the whole idea of linear programming is to also to maximize and to minimize. So in a business context, when you see the word maximize and minimize from LP, we are talking of increasing the profit. If the problem is about increasing, we increase the profit. So that goes with max. Then we have whereby now we are trying to lower the cost or decrease the cost. So this is how we put it in a business context. We maximize and we minimize. So for us to do this, like we are saying, this is a mathematical technique. So this technique, which is LP, there are other methods that are found under that. So the methods that you find under our LP, the first one we have graphical method. Two, we have simplex method. And at the same time, these two methods, they are conditions. For an example, if we look at the first method, which is graphical, we are saying graphical, we can only apply graphical method when we have two variables. So that's the only time we can use graphical method to solve our problem under linear programming. Then we have the second one, which is simplex method. So this one is where the problem now becomes complex. When I mean complex is where you find a problem we have two variables or more variables. Sometimes we can be given 3 variables.
Sorry, sir. It seems that you're talking on mute. Please, could you unmute? Hi, sorry, it seems that there's no volume. I'm not sure if you're talking on mute.
I actually don't see the lecture anymore. Does anyone see them?
He's probably restarting.
Okay.
Hello? Can you hear me again?
Yes, we can hear you now.
Okay. I'm sorry about that. That was load shedding. I was not aware that there's a load shedding. I'm sorry about that. Okay. Where was I? Okay. I was still explaining the two methods, or the two methods that you find under linear programming that we can use to solve any given problem of linear programming. And I said we have graphical method, and I said we can only apply graphical method when we have two variables. And I said the second method in the linear programming is simplex method, or others they call it simplex algorithm. So that one we can apply when we have two or more variables. So in this case, we're going to focus on our our graphical method. This one, we are not going to discuss it. Our discussion is mainly on your graphical method, linear programming, graphical method. But before we can start applying the graphical method, we'll go a little bit back, whereby now we have to understand solving this problem under LP, we have the LP standard form. So this standard form is going to show us our objective function. That's what we're going to get from our standard form of LP. Objective function. And we have our constraints. And we have our non-negativity. Our non-negativity. Negativity. Restrictions. So this is what you are going to see when you see our LP standard form problem. So remember, we said under our LP, we have two ways to solve the problem. So normally our problem, it comes as a max, where I said, where we see max, it means our interest is to see how the company is making profit, or how much the company is going to make as a profit. Two, there are problems where the company is trying to minimize. So it means when we talk about minimize, we are talking about where the company is trying to minimize the cost. So you'll see most of the problem, they will denote it as a P, knowing that, okay, they refer to profit. Others, they use C, you know that they refer to cost. So we have our mathematical standard form, then we'll start with, in the case of maximum. So when you talk about maximum, we say, okay, max, Z equals to C1. Okay, I think it's best if I started the new page. I don't have enough space here. I will say this is a max standard form. Standard form. So the max standard form, we say it's max. This max is maximum. Maximum Z equals to C1 X1 plus C2 X2 plus, depending on the number of variables that you have, Cn X subscript n. This is our objective function. Then we have ST. This ST stands for subjected to. Now we are referring now subjected to the following constraints. And we are saying our constraints, we have A11 X1 plus A12 X2 plus, depending again on the number of variables in our constraints, A1n Xn. So in the case of maximum, we use at most B1. Then we have the second one, which is 21 X1 plus A22 X2 plus A2n Xn as equals to B2. Then we'll go down until to the last constraint. So the last constraint there, maybe it will be M1 X1 there plus M2 X2 plus Mn X and there less or equals to B subscript M. Then these are our constraints. We have our objective up there and followed by our constraints. And we have our non-negativity, where we say we have Xij there, it's less or equals to 0. So we assume that our values, they must be positive. So this is our standard form of maximization. So when you are given problem, your problem can be given in different ways, but your problem doesn't matter how it's given to you, how it's presented to you. What is important? You must have your problem in this fashion. So after having your problem in this fashion, that's where now we can start solving your problem. So it means after we make our problem in the standard form, if our problem is maximization problem, so we have to put it in a standard form maximization. You can be given a scenario, which is a paragraph where information is there. You must be able to take the given information and put it in this fashion that you see here in the standard form, maximization standard form. Then it can be given, or it can also be given as a table where you're given a table. So you from that table, you must be able to come up with the standard form from the given information. Or sometimes can be given in this fashion. So if it's given in standard form, you don't need to do anything because now it's given in the right standard form. So all you need to do now is to solve it, applying, depending what is being asked. Are you using maximization? Are you not maximization? Are you using graphical method or are you using simplex? So in this case, like I said, we'll be focusing on graphical method. And I said, remember, I said to you, graphical method can only be applied when we have 2 variables. But once we start having 3, it means it's not applicable. So we'll take an example. If you look at your study guide there, where is our study guide? From your study guide, you are given a problem, and it is a maximization problem. So what is expected from us is to come up with a mathematical form of that problem. Oh, before I start going further, let me explain the standard form. This C, I'll just call it maybe the CIJs. This one. These are the prices of the items that we want to sell. So like I said, our objective, if we put it in a business context, since we are in camps talking about business. So this C, we are talking about our selling price of our products. So in most cases, we'll be given our selling price of each item. And like I'm saying, your objective function, it gives you that, okay, objective function present your selling price of your product. For an example, if we are producing tables and chairs, so it means variable 1, which is x1, it will be T, which stands for table, the tables that you're producing. Then we have C here for variable 2, which represent our chair. So here we know that, okay, we're producing our chair. We know each item or each chair is going to cost us maybe, let's say, 200 Rand. And here we have 400 Rand. This is a table. No, this is a chair, this is a table. Okay. So we're saying a table, each table is 200 and chair it's 400 Rand. So the reason we're applying this method, we want to know, for us to maximize our profit, how many number of tables and number of chairs we must produce. So our objective function is all about it. So coming to our constraints. Our constraints here, that's where we want to know, okay, if now time is involved, it means this B, it will be what is given to us. Maybe it will be budget or time that is available for us to produce number of tables and chairs. So here it will be, down here, we'll be talking about the raw materials and time that is needed for us maybe to produce, maybe to cut and do other stuff to come up with the chair, and there will be maybe painting involved. So you want to know how many hours is needed for us to come up with that. And depending on the types of tables and chairs maybe that you're producing, maybe the first one, it will be the steel, the other one is wood. So you want to know how much hours do we need for these 2 items to come up with final products and Like I'm saying, this 2, when it says less or equals, it means we can only go up to B1. For an example, if B1 is 2, let's say it's 200, let's say 240 hours. So it means for us to produce this 2 item of the first constraint, we are given less or equals to 240 hours. So whatever that we're going to do for us to come up with these 2 items, to finish them, we are working on 240 hours. So there's no way we can exceed that. We can only do 240 hours or less. That is acceptable. But once we go beyond, it means it's wrong. Okay. Any question before I take a problem, an example? Guys?
Questions?
I can't hear you. Questions before I take an example?
All
I
good,
have
Ms. Ekman.
questions, thanks.
No, please continue.
Okay, thank you. So if you look at the given example in our study guide, this company is producing a 2 product. They're producing boots and jackets. And we are given time, and like I said, we are given the prices. So it means from the given information, we have to come up with a problem that appears like this standard form. So from there, I'm having a problem. I can't see properly here. What I'm going to do just to write my table here. And this table, it will be presenting the given information. Like I was saying, depending how you want to make your problem simple. If you can, you don't need to come up with a table. You can just move from this. If you're given a scenario, you can just move from the scenario itself to write your problem in the standard form. But maybe if you want to make it simple, you can put it in this version of a table before you do a standard form. So we are saying, 1, we have 2 items that you are producing, which is boots, and we are producing our jackets. Then we have hours available. Then this side of production, we have making and finishing. Then below we'll be having our price. So in this side we'll write, okay, if we are looking at the boots, how many hours do we need to make a boot? Just to do the making of it, no polishing, not doing any fancy things, just to bring it together, just to give it a shape, a proper shape, to say, doing the cutting and everything, to say, okay, we can see this is the shape of a boot, this is a boot, if we have to describe it. Then we say we need 4 hours there. And we are saying to finish it properly, to say, okay, now this boot can be able to sell it. It says we need 3 hours. Then we go to the jacket now. We say for us to do the cutting and everything to come up with this jacket, we need 2 hours. So to make it now sellable, now we're saying it's a finished product, we need 4 hours to do that. And we are saying the selling price, which is C in this case, CIJ. For the boot, it's 1,200. And for jacket, we have 900. And we say
Sorry, sir.
Now,
The
how many
price is
hours?
vice versa.
Pardon?
For jackets, you have 1,200 in the book, and for boots, it's 900.
You're talking about our prices.
Yes,
Hello?
I am. Yes, if you are going according to the book.
Okay. Then here it's 900.
No, it's the other way around. It's 900 for the boots, and it's 1,200 for the jackets.
What did I write firstly? You are saying this is 1,200.
No, the boots is 900 according to the book, and the jacket price.
We're talking
is
about the prices. We're
1,200.
talking about the price, not time available.
Yes, no, price, according to the book.
The price is 900.
900 for the boots and 1,200 for the jackets.
Okay. 900. Okay. Then we have 1,000.
It's 1,200. Yes, that's correct. Thank you.
Okay, thank you. I don't have a study guide
Sorry,
with me, so I'm using a scribbler somewhere.
sorry, sir. Sorry to disturb you.
Yes.
But the study guide does the opposite. So what's correct?
Just give me a minute. Because I'm using my scribbler, I can access some of the things. Let me go to.
I'm not disputing. I'm not disputing what the lady said, but I mean, in the study guide, it's the opposite. It's the other way around. No, I don't know now.
But just wait. I want to check the study guide before I comment. Because now I have a load shed in this side, so I can open some of the document. I'm sorry about that.
Maybe someone can take a screenshot of it and paste it in the chat, Mr. Klav.
Yeah, maybe that would work for me, so I can be able to see. Is someone posting it? Okay, I think I got my study guide. Okay, here is our problem. Are we able to see, all of us?
Yes, so we can see your scribbles.
Yes.
Okay, if you look at the problem, it says a manufacturer of leather, a manufacturer of leather articles products produce boots and jackets. The manufacture process consists of two activities, namely making, which is cutting and stitching in brackets, that's making, and finishing. So it means these are the two processes that jacket and boots must go through. So we can say now we have this jacket and boots. There are 8 hours labor hours available per month for making the articles and 1,200 hours for finishing them. It takes 4 hours to make a pair of boots. So it means if we look at our table, go back to our table. Okay, we are saying it takes 4 hours. This is correct. It takes 4 hours to do that, just to make a box. Okay, and it continues. It says 3 hours to finish the same product, which is our box. And it's correct. Here it is as 3 hours. So the question continues. or the statement continues, it takes 2 hours to make a jacket. Just to do the making, cutting, and everything, it's correct. Here is our 2. And furthermore, it says 2 hours to make a jacket and 4 hours to finish it, what, the jacket. So we have 4 hours here. We are fine with that. And the last part saying they sell a pair of goods. This is a pair of goods with 1,200. So we have 1,200 here. So it means each pair, a complete pair of goods, is 1,200. And jacket, each jacket is selling by 900. So this is our selling price. 1,000, that's for both selling price. Each pair of goods is 1,200. Jacket, 900. Okay, the only thing that we skipped, okay, is about the hours available for us to come up with these 2 in a month. So we see the labor available for making, it's 800. Then we have the hours available in a month to have a finished product, which is 1,000. 1,200. Are we together now?
Yes.
Yes, we are together,
So
but
this
if
is-
you take a look at the table in the study guide, page 32, it's actually wrong in the study guide.
the table.
Yeah,
I've got a print screen of that if you want. I can share it.
it is in the comments.
No, I don't think it's
Okay.
wrong. I think it's correct. It's correct.
No.
This is the table from the study guide. The price for both is still 1,200 and jacket is still 900. So which is the same as what we have here.
Yeah, but the table states it's 900. The price is 900 for boots and the price for jacket is 1,200. If you take a look at the table, not your table, the table in the study guide.
No, this is a study guide, ma'am.
Yes,
Unless we're
it
having
reads
different
they
study
sell a
guides.
pair of boots for 1,200 and a jacket for 900. But if you take a look at the example in the study guide, the structure of the information, it tells you that it's 900 for the boots and it's 1,200 for the jackets. That's where the confusion is coming in. So the study guide is then actually wrong. The table in the study guide. Quickly see the comments. There's a picture of the table.
The hard
Oh,
copy
you've shared it.
Yeah.
It's
Pardon?
the
hard
hard
copy
copy.
study-
I agree with her.
The hard copy is
swiped.
wrong. Yeah.
Yeah.
Oh, the hard copies.
No.
Okay, I don't have
Yeah.
the hard copy.
Yeah.
Okay.
The one provided on the site or provided on the portal itself under the courses is correct. That's the soft copy one.
Okay.
Yeah.
Okay, thank you, sir. Okay, let's continue. Remember, I said to you, it can be given as a scenario. And if it's given as a scenario, it's up to you. If you want to simplify it or you feel like if from the table you can write it correctly, it's fine. But if you think from the scenario itself, you can just come here, it's still correct. You don't need to do this table. Are we together? So this table is trying to simplify our problem, but it's not necessary to do it. So now we have this information and we are saying we are maximizing. So when we are maximizing, we are going to say, you can use P, it's still fine, or you can use max. Like I was explaining earlier on, P represent profit, which is we are maximizing, is the one and the same thing. So we are saying max Z equals to, remember I said this is our selling price per item. And I said selling price per item, they form our objective function. Where objective function, I said it's C1 x1 plus C2 x2. I'm writing it like this because of now we're only having 2 variables. So it means C1, it will be 1,200 and C2, it will be 900. So that's where we have 1,000, 1,200 x1 plus 900 x2. So as I was explaining, so it means our objective, we want to know number of these two variables, x1 and x2. How many items should we produce for us to maximize our profit? So that's the whole idea. So we have 1,200 x1 there plus 900 x2 subjected to the following constraints. So this is our constraints. So our constraint is going to be 4x1 plus 2, is it 2? Yes, 2x2, which is less or equals to 800. That is the first constraint. The second one there is 3x1 plus 4x2 less or equals to 1,200. So our non-negativity restrictions, x1 and x2, it's greater or equals to 0. So now our problem is in our standard form. So now we can apply one of the two methods that I've mentioned earlier on, which is your simplex and graphical method. But in this case, we are going to use graphical method. So our objective is to find the two values that are going to maximize our profit. These two values, they will be representing x1 and x2. But for us to do that, our focus is going to shift now, for now, to our constraints. Now we want to have two values, like we are saying, we are using graphical method. So it means these two equations, we are going to use them to do our graph. So we'll be having two lines that will be representing these two equations that we see here, or these two constraints. So from there, we'll be able to get our information. And the reason we are graphing this, we want what is called feasible region. So these two equations, they're going to help us to come up what is called feasible region. And we are saying this feasible region is where our possible solution lies. So what we're going to do, we'll take the first equation. And if you remember what we did when we were dealing with your demand linear function, supply linear function, a similar approach. So we'll convert this inequality sign to equal sign. So remember, our objective is to have two values from this first equation. Let's say this is equation 1, step 5. So what do we do now? We let x1, let's say x1 equals to 0. Why? Our interest is to find x2. So we say, okay, where we see x1, we can put 0. So it means in this case, we'll be having 0 there, x1 plus 2x2 equals to 800. But our interest is to have 2, rather x2. So we'll have to get rid of this 2. How are we going to do that? Let me just repeat it, just to make it easy. We divide both sides by 2. Then we ended up having x2 there equals to, are we together?
Yeah.
So
Yes.
we are going to do the same. We're going to do the same thing in, remember I said to you, guys, we want from this equation. From this equation, we say we want two values that will represent x1 and x2. And if you remember in our previous classes, when we start demand and supply, we're talking about x, we're talking about y and p, x, q, and p. So it's still the same approach, if you remember that, where we started doing our graphs from our linear equations. So we take the very same now. We do the same thing, which is 4x1 plus 2x2 equals to 800. Then now our interest is to know what is the value of x1. So if we want x1, now we say let x2 equals to 0. So where we see x2 in this above equation, we replace it by 0. So we have 4x1 there equals to, or before I say equals to, just to follow the steps, we have 2 times, now we put 0 equals to 800 rand. Then we ended up having 4x1 there equals to 800. Then we divide both sides by 4. Then we ended up having x1 there equals to, do we follow, guys? Hello?
Yes, sir, I'm following.
Okay. Remember, this is the first constraint.
Sorry, sir, I've got a
So we are
question.
going to the,
Hi,
yes.
sorry, I couldn't raise up my hand. I've got a question. Okay, in the place where you've actually calculated for 4x equals, sorry, just hold on. Okay, where we've calculated x2 equals 400. Okay, can I not actually substitute like how we did in the previous modules, where we substitute 4x, well, the value for x2 for 2x as well, but then we actually get 0. So I'm sure that's, it's not the way
I
to go.
didn't hear you.
Okay, see
You were
on
saying,
top.
let's go back a bit.
Okay,
Okay.
we've actually calculated the value for x2, which equals 400.
And it's
Okay.
400? Yes.
Yes. Okay. So then we go back to the sum where it says 4x1 plus 2x2 equals 800. Okay. So can we not substitute the value for x2, which is 400, and substitute it there in the sum? Or do we have to do this method?
No. No. Remember, we want to do a graph. So if we do a graph, remember our graph is going to be like this. We want to have the value that represent y and x from this equation.
Thank
Because
you.
now if you take, like you are saying, if you take, let's just finish it for argument's sake. If you take this 400 and you put it here, you see you ended up getting what? Getting 800, right?
And then I got 0, which
Then
is
you get
incorrect.
0. So what is going to be the value of x1 now? Because x1, it has to have a value that is going to represent it in this Cartesian plane. As the same as this value represent our x2 in this graph that I'm having here. This is x2, this is x1. Do you follow now? The idea
Yes, I
is to
do.
have
Thank
the
you.
2 straight lines. The idea is to have the 2 straight lines that represent these 2 equations. Okay. So we know now we have 400, which is x2, and we have 200 for x1. So what do we do now? We say, okay, we are going to do exactly the same thing. Now we are using the second equation, which is 3x plus 4y. 3x1 plus 4x2 y equals to 1,200. So we do the same. Let x2 equals to 0. So we let x2 equals to 0. Why? Because we want the exact value of x1. So when you do that, we say x1 there plus 4 times 0 equals to 1,200. So there's your 3x1 equals to 1,200. Then we divide both sides by 3. Then we have x1, which is 4. Then we do the same again. I'm trying to save the space. I can just do this and say 3x again plus 4x2 equals to 1,200. Now, our interest is to know the value of x2. So we let x1 equals to 0. Sorry. So in that case, there you go. Plus 4x2 equals to 1,200. So this will fall off. We end up having 4x2 equals to 1,200. So we divide both sides by 4. And we have the 300. So we have 400 and 300. We have 200 and 400. So these values, these two, they represent this equation from the given information. So these two values, which is 200 and 400, they represent this equation in our graph. So what we are going to do now is to do our graph. Remember, the reason we are doing our graph, we want to find the area that is called feasible region. Where I said feasible region, it's a set. Feasible region is the area where our possible solution lies. So here is our graph. We have x1 the side and we have x2. So we said the first equation is made up of 400. Just put it here, 400 and 200. Then our 200 will be somewhere here. And the second one, if I remember well, okay, yes, we have 300. Put our 300 somewhere here. And it goes with 400. Okay, so these values that we see, they represent the two linear equations that I mentioned earlier. And we're saying we have, this is the first line, and this is the second one. Okay. So I'm going to label it just to remind you that 3x plus 4x, 3x1 gave us 400 and 300, 400 and 300. So the equation there is, you'll correct me, is it 3 or 4? Okay, it's 3. The equation there is 3x1 plus 4x2 equals to 1,200. So it means from this equation, these are the values. So it means these two values, they represent this equation. Then the second equation that we have is the equation of 4x1 plus 2x2 equals to 800. So from this equation, we managed to come up with 400 and 200. Okay. So now because of we managed to do our graph, the next step, if you remember, originally we had at most less or equals to, less or equals to. So what we want to do now, we want to use the given information now to do what is called our feasible region. So it means to know our feasible region, it means we look at the original sign of our equations. So we can see the two signs are the same, are similar, and they're saying less or equals to. It means we're moving inside. So it means from these two lines, that represent these two equations. So it means we are going to shade according to the direction of the inequality sign. And this two inequality sign, it's less or equals to. Even this one is less or equals to. So it means now we'll have to find the line representing these two equations. So the first equation is this one, which is equation 1. This will be 2. So we say, okay, this is the line. This is the line of equation 1. So it means now we'll have to shade from that line following the inequality sign. This sign, it says we are going inside. So it means we are shading from that line. We don't go beyond. We just follow the direction of our inequality sign. And we shade from that line. So it means this is how we're going to shade. It's unfortunate I don't have different colors. I only have this one. So we shaded following the inequality sign from the line that represents that equation. So we say, okay, we come to the second equation. Second equation, this is the second equation. And look at the sign, it's still the same. It's less or equals to. So meaning we are going to shade from that line, the given line, the calculated line going inside. We are following the inequality sign. So this is the line that I'm talking about. So we are going to shade going inside also. I will do it like this so you can be able to see different lines. I hope you are able to see. The others are straight, the others are not. So why are we doing this? Why are we shading like this? Remember, I said to you, feasible region. It's a region or an area where now, again, all these colors meet. If it was supposed to be colors, or all these shapes that I tried to do meet. So we have two lines here. We have two equations. So from these two equations, we can see, we can recognize there are two, maybe two shapes or lines. I don't know what to call them. So we are saying that area, we are looking for that particular area where the shapes of these two meet. If you look at this area here, this one, we can only see one line, and which is not straight, which is not straight. So we are saying we want the area where we can find the straight line and the other line, which is not straight. So that area, that's the area we call it feasible region. If you look at this one again, like I said, you can only find the lines which are not straight. And we come to this small area here. Remember, our interest is only in our first quadrant. So if you look at this area again, this one, we can only find one line. And we can say those lines are straight lines. The lines there are straight lines. So if the lines are straight lines in that portion, that's the only lines that you can find. It means that is not a feasible region. So a feasible region, guys, is an area where we can find both the straight lines and the other lines which are not straight. And if you look at the area that I'm talking about, this is the area that I'm referring to. So this area, you can see, you can find straight lines. There are straight lines there. And also, there are this type of lines. They also found in this particular area. So now we can shade it, say, okay, this is our area. Why? Because both lines, we have two equations that are represented by two lines. And they show us this is the feasible area or feasible region. So it means our possible solution, it's somewhere in these corners. One, this corner, and this corner. So it means our feasible region is made up of 4 corners. Questions before I continue? Guys?
I'm good with questions, thank you.
Good, thanks.
Okay. So now we know our feasible region. So maybe we can say this is A. Let's say this is B. Okay, let's say this is C. And this is D. Okay. So now what we are going to do, we have values here. So we have to put our values here, where we say, okay, maybe for this one, we have 0, 0. So it means 0, 0 represent A. A is 0, 0. Then our B there, we have the value of x1, which is x. So in that case, our x2 in that case is going to be 0. Then here, there's an unknown. Then we have here C, we have 0 that goes with 300. Right. So what we're going to do now, we have to find this unknown point. And for us to get this unknown point, it means there are two lines that intersect at that point. So it means for us to know what is the values of D that represent X and Y, or that represent X1 and X2. So it means we'll have to take the two equations that intersect here. So in that case, the two equations that intersect here, these are the two equations. So it means you can apply your simultaneous, or you can equate these two like we have done when we're doing is it supply and demand, but there's somewhere, or when we're doing elasticity, there's somewhere where we're equating two equations for us to find two values that will represent our x1 and x2. So it means in this case, these are two equations that intersect here. So let's apply a simultaneous equation to solve our problem. We have 3x1 plus 4x2 equals to, then this is the first equation. The second equation, 4x1 plus 2x2 equals to 800. Anyway, so what do we do now? Okay, we can apply elimination method or simultaneous, not to equate. Okay, so what do we do now? We have to choose one of these two. Which one do you want to simplify it and solve our problem? Which one can we take?
The bottom one.
The first one.
The bottom one. Okay, so let's take the bottom one and try to create equation 3 from the bottom one. Okay, the bottom equation is 4x1 plus 2x2 equals to 800. So we're trying to create equation 3 from here. You can say, let's say, create equation 3, maybe from equation 2. Okay, so what do we do now? We are trying to simplify there. Okay, let's say we have 2x2. Then we take this to the right-hand side. And when we do that, we ended up having minus, because it was positive. So going to the other side, it becomes negative. Okay, so we simplify this. We have x2 equals to, when you divide there, 400. And we have 2x1 there. Then we can say this is equation 3. Do you follow, guys?
Yes.
Are we still together? Okay.
Yes, we are.
Yes,
So now
yeah.
we have equation. Okay, thank you. We have our equation 30. So from equation 3 now, what we're going to do is say, let's substitute equation 3. Remember, we created equation 3 from 2, so we are not going to repeat that. We substitute equation 3 into equation 1. So let's go and check what is equation 1. Okay. Our equation 1, there's 3x1 plus 4x2 equals to 1,200. So remember, we are saying substitute equation 3 into 1. This is 1. So this is how our equation 3 looks like. So we are saying x2 is equals to 400 minus 2x1. So it means where we see x2, now we can put this part on our right hand side. So we say we have 3x1 plus 4 open brackets. Now instead of now writing x2, now we can say 400 minus 2x1 close brackets equals to 1,200. Okay, so now we're simplifying this. We have 3x1 plus 1,600 minus 8x1 equals to 1,200. So what do we do from here? We group the like terms. So when you group the like terms, this goes with that. Then we have negative 5x1 there equals to, if we take this to the other side, where we have, what do we have? 1,600. Okay. That's going to be negative. Is it negative 4, right? Guys, are you with me?
Yes.
Yes, it is.
Yes, minus 400.
Okay. So what we do now, we'll have to now get rid of this. Negative 5. Negative 5. So what do? We divide by negative 5 both sides. What is our final answer? What is the value of x1?
80.
Minus 80. Positive 80.
18, 18.
80.
80.
50,
80. 80.
80.
Yes.
Okay, thank you. Okay, so we have x1 there equals to 80. So remember, we used equation 2 to create 3, and we substituted 3 into 1, but we have never used equation 3. So what we are going to do now, we're going to take now equation 3. We say substitute x1 equals to 80 into equation 3. And remember, equation 3 is x2 equals to 400 minus 2x1. So it means where we see x1, we can put now our 80. Two times 80 minus 160. What is the value of x2? Yo.
240.
The answer is 240.
240.
240. Okay. So it means the unknown point now, we know that we have our x2 here is 240. Our D there. We said our X1 is how much?
80.
80.
80. Then we have 240. Okay. Questions? Questions?
No
No.
questions?
Okay. Okay. So now what we're going to do, I'll just create a table down. Going to erase. Check where can I erase? Okay. I'll just erase here because we know our values. Just to come up with a table. Okay. So I'll just do a table here. So our table, okay, we'll have, I'll say A, we have 0, 0. We have 0, 0. Here, I'll just put, maybe let me put my Z here. Here we'll have our X1 and X2. Then we have our A there. We have our B. Our B, it was 200, if I remember well. Our X there, it was 200 to 0. Our C, it was 0 to 300. You'll correct me. And the last one, which is our D, we have 80 to 240. Then, if you remember our problem, we had, not our problem, our objective function. Our objective function, it was 1,200 X1 plus 900 X2. Okay. So this Z will represent, if you remember, we said max Z equals to 1,200 X1 plus 900 X2. So this is our C, remember? This is ourCij's. So we say in the point A, we have 1,200 times 0. This 0 is from here. Then we have 900 this side times 0. We are using our coordinate points that we have. Then we ended up having what? 0 there. Then we have 1,200 times 200. And we have 900 times 0. What is our answer? 1,200 times 200.
It's 240,000.
Pardon?
240,000.
240. 240,000. Okay. Then we have 0 here. 1,200 again times 0. And we have 900 times 300. What do we have?
270,000.
270. thousand. The last one, we have 1,200 times 80, and we have 900 times 240. What is our answer?
312,000.
312,000. Okay, so we have 0, we have 240,000, we have 270,000, we have 312,000. So what do we do now? Remember, our objective is to maximize the profit. So what do? We're going to compare these values that we find in the column of Z. So we say we want the maximum value. So in this case, looking at this information and based on our calculations, the maximum value is this one, 312,000. So we say our Z max is equals to 312,000. And where X1 is equals to 80 and X2 is equals to 240. So we are done. So going back to our problem means for us to make this profit, that tells us that okay, there's our problem. So it means for us to make that profit, which is 312,000, that tells you that it means we have to produce 80 pairs of goods and 140 jackets for us to have that profit. Questions?
So just repeat your last point again, please.
Okay, my last point is, remember we calculated we calculated different values of Z. Or go down. Okay, these are different values of Z. And remember, these values that you see, they form this part of, where is it? Where is our graph? Okay, we took the values that you see to calculate from this. So it means these 4 points are the points that we used. And if you remember, I said to you, our feasible region is where our possible solution lies. So our possible solution is lying at this 1, 2, 3, 4 corners. And we took the values, the coordinates of that 4 corners. Here they are, 0, 0, 200 is to 0, 0 is to 300, and 80 is to 240. So we use those two and take our objective function and substitute the values in our objective function, whereby we want to find the maximum values. So the maximum values that we got, we have 0, we have 240,000, 270,000, 312,000. So we say the maximum value here is this. So it means this is our profit. But now, this profit, what does it mean? It means, okay, from this, we know we are selling each item of goods by that. So it means to maximize our profit to that 300. That tells us we must produce 80 pairs of goods and we must produce 240 jackets for us to have 312,000 as a profit. Are you fine?
Yes, thank you, sir.
Okay. So this is maximization problem under LP. And we are left with, our laptop's going to die, and we are left with 12 minutes Now we have to do minimization. Can we have class on Wednesday? I know it's a public holiday. Is it possible to have a class?
I would be fine with the
Yes.
class. Thank you, sir.
Yes, it's possible.
It's fine,
It's
thanks.
possible.
Yeah.
So what time can we have it? Because now I want us to finish. There are two parts that I want us to do the second part of this linear programming, which is minimization, and we can do the break-even point. What time can we have our class? Because it's a public holiday.
Isn't morning a bit better so that everyone can carry on with their day?
Okay, I'm fine with that. What others are saying?
Morning what time?
Maybe 8, I don't know. Between 8 and 9, we can start our class.
Can we rather make it 9 o'clock?
Or 9 o'clock. Okay,
Perfect.
if you are fine with 9, I will set up a Atlas discussion for 9 o'clock. Wednesday, 9 o'clock.
Okay.
9
thank
o'clock.
you.
Yes. Okay. Thank you. If you have questions, guys, don't hesitate. You can just post it under our discussion. So I will answer you.
Thank you so
Thank you,
much,
Mr.
sir.
Kaba.
Appreciate it.
Okay. Okay. Thank you. Let's meet on Wednesday, 9 o'clock.
9 o'clock. Okay. Thank you.
Thank you.
Bye.
Bye.
Okay. Thank
Bye-bye.
you.
Bye.
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 Hi, sir. Sorry, I've got a question.
Yes.
Okay, I
Yes.
think on last Wednesday, we were supposed to have a session, and I think it was actually scheduled for 5 o'clock. There were only 2 people available, so I'm not sure. And I think you were supposed to actually cover actually page 17. That's the applications of simultaneous functions and equilibrium. So I'm not sure if you did have a session and I missed it.
No. Okay, I said in that session, I'll have a recording. So you'll find a
Okay.
recording there. Just put a recording for that session. But I said I will start the session afresh from the scratch, do the whole session and put it on your module site and on YouTube.
Okay, perfect. Thank you very much.
Okay.
Thank you. Bye.
Okay, thank you. Bye.